All right. Software engineering, the Genesis. It sounds like a movie, right? How many of you guys could call themselves software engineers? Raise your hand. All right, almost all in the room. The rest of you guys, you can kind of sit, relax, enjoy, and see how miserable our industry is. They say that out loud. Okay, so the question would be, what does it mean to be a software engineer? Can somebody give me a definition? I mean, if your definition is going to be writing software, then I can share my story. A few months ago, I went downstairs from the office, and my 7-year-old son asked me, "Daddy, why you look so tired?" And I said, "You know, son, I was working for 12 hours. "Really? But all you do is pressing buttons." So do we really, that's all we do, pressing buttons? I hope not. So the question about what is to be a software engineer, what is software engineering, is kind of complex. So let's ask ourselves a better question. Where actually software engineering, the term, was first used? As it turns out, the term was used in year 1968 at the conference held by NATO. It was an international conference, and the cool thing about, and the conference was actually called Software Engineering. The cool thing about this conference is they actually have a full transcript of the conference. So every talk submitted, every discussion panel that they had, you can actually read it. The funny part is that they used the term software engineering to be a little bit provocative. They just realized at this point that the industry was moving a little bit away from theoretical practices and disciplines as other branches of engineering were at that time. So they gathered like 50 experts. And when I say experts, I really mean like founding fathers of our industry, like Dijkstra or Alan Perel. So like really wise guys, and they were all in that room discussing about the problems of software engineering. And you might be thinking, you know, come on, it's been half of a century, right? What we can actually learn from the guys who are writing software 50 years ago, I mean almost 50 years ago, right? I mean, the industry obviously made a progress from the 70s, late 60s, till where we are right now, right? Right? But then I read this. A software system can be designed if testing is interlaced with the designing instead of being used after the design. Wait a minute. Writing tests while writing my software is better than writing software and then testing it. Where I had that before. That's basically test-driven design, right? It's basically what it is. Let's check another quote. The good systems are presently working where we're written in small groups. More than 20 programmers working on a project is usually disastrous. How many of you guys have been on a dev run, right? Did you ever had a manager who would say like, if I double the size of my team, the outcome should be twice as fast as we're doing right now, right? You had it in your projects? I've been in those projects. But those problems were discussed 50 years ago. All right. They also discovered something simple, that your development, the process of developing your software is also coupled with the organization for which you're writing your software. The structure within the organization matters. Communication in the organization matters. The way how decisions are being made in the organization matters. This is 101 domain-driven design. This is basically what they teach you about when you learn about domain-driven design. One more time is 1968, right? Okay. And there's also like some people might say, oh, this is a little bit agile. But come on, agile. They obviously we're talking about agile in 1968. Well, they actually describe how you should properly create your software. So they say, first go to the whiteboard and think about the problem and try to understand it. Then write the code until you realize that you don't. Go back to the whiteboard and redo it, and then run more code one more time and do it in an iterative process until you actually reach a solution. It's agile. Okay, but then you see this, one of the diagrams that you see, and you're going to be, waterfall, right? I knew it. Well, one of the experts brought this diagram during the conference, which immediately spawned a discussion. And they immediately said, okay, we have this kind of process, but then again, we need a while loop that will tell us, and we will be able to introspect during the development process. If you're still not convinced that Agile was actually discussed at that conference, let me quote you this. There was one of the experts who was telling a story of his experience of the latest project that they were actually developing. And this is what he said. Design and implementation proceed in a number of stages, iterations. Each stage was typified by a period of intellectual activities followed by a period of program reconstruction, which is, you know, all those little things you learn in Agile. Each stage produced a usable product, and a period between the end of one stage and the start of the next stage provided the operational experience, meaning the product was actually deployed somewhere, upon which the next design was based, meaning we got feedback from our users, and then we can actually think about the design for the next stage. In general, the products of successive stages approach the final design requirement. Each stage included more facilities than the last one. If that isn't the definition of Agile, then I don't know what it is. But speaking of Waterfall, how many of you guys actually read the paper? Not many. But do you recognize this picture, right? Waterfall is the biggest irony of our industry. Because if you actually read this paper, and it's not really big, immediately after this picture, the author of the paper is saying, this is bullcrap. This will not work. It's risky. It invites failures. Because most of the time, when you actually will be doing testing, you will learn about those things like reliability. Users will tell you this is actually not what I was hoping to get. And this way of writing software will not work. For whatever reasons, people were reading the first 2 pages, they saw the diagram, they were sold. Nobody actually read this. We have 2 hard problems in computer science. One is cache invalidation, and the second one is naming things, and also off one by error, right? But I would be thinking that naming things actually isn't our problem. This is what we basically do all the time. We constantly rename things. That's all we do. You don't believe me? Let's talk about microservices. What are microservices? I know it's not really a fair question, because if we actually got like 5 experts on microservices and asked them this question, they would give us like 6 actually answers. So let's ask a different question. What is the difference between microservices and services object-oriented architecture? Well, we could go, for example, to Martin Fowler's blog post, and he answers that question. And he will tell us, well, microservices, well, they actually are SOA, but they are very, very concrete terms. SOA became so abstract, so vague idea, and we actually needed something very, very concrete, something that we actually can name. Okay. The only problem is that if we actually try to do a little bit of research about SOA and how it actually was created and invented in our industry, what we will learn is that Alexander Pashik, a former analyst at Gartner, coined the term SOA because he thought client-server architecture is a little bit vague, and he needed something very, very concrete. Do you see the pattern here? Right? But that's not the end of the story. Oh, and by the way, if you already feel insane, underneath your chair there's like a crazy pill you can take and you'll be just fine. But basically, this paper is just awesome because one of the things you will actually learn in this paper, the guy will tell you that SOA, when it was coined in the middle of the 90s, they didn't really actually invent the way to write software. They just named the way the software was already designed since the late 70s, early 80s. All we do is rename existing stuff. But you might be saying, but come on, some problems at least are solved during that time, right? Well, if you really talk to people who were doing SOA before and now doing their microservices, they will tell you all the problems that they had before are still not being resolved. The biggest problem in microservices is how many lines should I have in my single microservice. That's the biggest issue, apparently. But it's not only microservices. Let's talk about programming languages. Recently, Go designers said they don't really need generics, right? They just said like, well, let's just drop 30 or 50 years of research because why the hell? But then you will find an awesome thing when you actually Google funny things about Go. There was a guy asking a question on Reddit. You've seen it, right? It was like, I felt like Go shouldn't have generics. And then the answer is brilliant. Well, if you really close look at it, it's not really generics. We are actually using a sign from Canadian Aboriginal syllabics block, which is allowed in Go. And from Go perspective, that is just one long identifier from which I'm creating 3 different files. Remember, sanity pills underneath your chair. So what is software engineering? I wouldn't be saying we should be called ourselves software engineers. I would say we should be called software craftsmen. And I'm not saying this in a good way, like Craftsman Manifesto. I'm saying that we sort of learn new things as in, I don't know, blacksmith was passing knowledge from generation to generation. What we learn is what we get from our colleagues, from our companies, and so on. I don't know how it is in US, but in Poland I've seen job description looking for senior Java developer, experience 2 years. Senior, 2 years. That's just crazy. Who to blame? Obviously, I know how the market looks like, and supply and demand, and there's big demand for software engineers, and it's also very easy to become a software engineer. And it's not that you don't really have to study and all that. But I always truly believe you want to see a change in the world, start with yourself. And before you actually do stuff, do some research. Try to reason that maybe somebody actually had that problem before, right? There is a light in the tunnel, and I hope that's functional programming. Because if you really think about functional programming, let's take monad transformers, for example. Monad transformers, they solve one concrete problem. There are other ways to solve that problem. Monad transformers is not the only way to solve this particular kind of problem. But never in the history of functional programming, you will not see monad transformers discovered in the 80s being named monad stackers in the 90s or whatever. None of those crazy renaming things actually doesn't work. And if you want to learn functional programming, if you go to papers which are written right now, those will look like some magical scripts that you will basically not be able to understand. And the way to learn functional programming is to go from the basics, learn papers from the 80s, then from the 90s, then from our century. And this is how you progress as a software engineer. My name is Pawel Szulc. I have 10 years of professional experience as a software engineer, and sadly, that doesn't mean anything. Thank you very much.